Creating good graphics is a very important part of data visualization. So I think it's important to talk about some of the ways in which you can really create good graphics, some of the principles that really lend itself towards data visualization in an effective way. And the other part about this is that a lot of applied statistics entails graphic design, entails creativity. And especially in recent years, the whole topic of data visualization has really had a renaissance within statistics because people are finally understanding how important it is and actually how difficult it can be to present a set of data effectively. So let's go over some of these principles for creating good graphics. So here are some things to avoid: biased labels, misleading scales, having no scalar labels on any of the axes, excessive visualization, so this is sometimes called a low data to ink ratio, which we'll cover in just a moment, and then unequal areas. In other words, a really violation of what's called the area principle. So let's go over these. Biased labeling is one of the things you should really avoid when creating a graph for statistical purposes. You really should just avoid loaded words or phrases that might prime the reader in a way that really biases the reader. So in this case, we have a bar graph, and we really have this biased label for the lowest category. It's really pejorative, and you should really avoid that. Try to be as neutral as possible in the labels for your categories, for your titles, for really as all the labels and information that you put in text on a bar graph. Try to make it neutral and just really try to convey what's going on. The data should speak for itself. Another thing you should avoid is misleading scales. In other words, avoid truncated scales, so really shortening the scales to artificially inflate the effect size, or you should avoid irregular scales. So here's an example in which we've truncated the scale for frequency, the number of counts. And you can see the scale jumps from 0 to 300, but it's not quite apparent. And this sort of truncation of the scale really makes it look like the lower class number of counts is vastly more than the middle and upper class. And it makes it appear that the upper class and middle class are extremely small. It's really artificially inflating the number of counts visually in the lower class. So try to avoid a distorted or truncated scale for your axes. Another problem that can go on is having no scale or labels. So you should make sure to include all appropriate scales or labels with the point to convey your findings effectively. So in this case, we have this bar graph. It's the same bar graph of passengers on the Titanic by class. And you can see that there's no scale. So it's unclear whether this is a bar graph of proportions, percentages, counts, or something else entirely. So always make sure to include a scale or labels. Another problem could go awry if there's no sort of labeling of the different categories. So if we avoided lower, middle, and upper class labels, and there were no labels, that would also be misleading. So always make sure that you're putting in the appropriate labels so that your reader can interpret your findings. Something else that is quite common in data visualization that should be avoided is excessive visualizations. In general, you should avoid excessive decoration or visual clutter. This has been called a low data to ink ratio. Okay? What you want is you want a high data to ink ratio. The general idea is that any graph you create for statistical purposes, it should convey as much information about the data, so it should have a high data to ink ratio. So what really constitutes a low data to ink ratio? Meaning, what constitutes a graph that doesn't say much about the data, yet spills a lot of ink? Well, redundant information, if you have colorings that it's just really not informative, that's unrelated to the data, if you have overly fine-grained axes, tick marks, any of this sort of excessive visualization, that can really lead to this low data to ink ratio that can really overwhelm the reader and really add this sort of clutter that makes your statistical graph misleading. Now, this is not a science, this is an art. This is where statistics is about graphic design. But I think if we go through a few examples, you'll see sort of what should be avoided. So here is a statistical graph of passenger class on the Titanic. So you can see we have lower, middle, and upper classes. and then the axis is labeled. But we have this legend, also called a key, and it shows the different colorings and what the labels are. The problem is that this is totally redundant. It's excessive decoration. You don't need it. And it can actually just be misleading because the reader might think that it's something else different. And it's also just pretty ugly if you have all this redundant information. So we want to remove that. But once we've removed it, you can see the colors of the different bars. They're also not needed because they already have different labels. The reader already knows that these different categories are part of the same categorical variable. So we should also avoid the color. So when we remove the color, we have this kind of bar graph. And this is really better. This is really a bar graph with a higher data to ink ratio, meaning you're saying more about the data with less ink on the paper. So it's useful to compare these two graphs. The one graph has a low, relatively, data ink ratio. The other one is a high data ink ratio. You want to say as much about the data with as little ink or visualization as possible. Another problem that can occur in creating a statistical graph is unequal areas. The basic idea of this is called the area principle. The sort of snapshot idea of it is that the area occupied by any part of a graph, it should correspond to the magnitude of the value it represents. And so one thing you should really avoid is 3D visualizations, because this can really violate this idea of the area principle. It can imply that certain wedges or certain bars are much larger than the other just by virtue of the way they're presented in a 3D context. So here's another example in a 2D context of violating the area principle. This is just the same bar graph of counts for the different categories of the passenger class variables. So you can see we have lower, middle, and upper classes, and then we have a number of counts. However, but the lower class, that lower category, it's a much larger bar, just width-wise, which is meaningless. There's nothing about the width that is informative about the data, and it implies many more observations in that lower category than actually exist. So this is really a violation of the area principle because the size of the bar is not in relation to the magnitude of the value it represents. So in general, things to know for this discussion about categorical data when you have a single categorical data variable and you want to create a table or visualize it. A frequency table will give you the counts for each category of a categorical variable. To put it another way, a frequency table gives the counts for each level of a factor. It means the same thing. A relative frequency table will give you the proportions or percentages for each category or level of a categorical variable. And bar charts and pie graphs can be used to visualize a categorical variable, and in general, you should really strive to present information from your data set as clearly as possible without distortion. And with that, that concludes our discussion of part 1 in our broader discussion of categorical data.